Hi guys. So this week we're going to be comparing linear, quadratic, and exponential functions in a different way. So last week we were comparing linear, quadratic, and exponential graphs. This week we're just going to focus on tables of values. And it's been a little while since we've talked about tables. We had talked about linear and exponential tables when we learned linear and exponential functions. We hadn't quite yet talked about quadratic tables. And I figured that I'd save them for this unit because I knew that I was going to be reviewing at the end. So I'm going to teach you guys about quadratic tables in this lesson. And then we're just going to be able to compare and see when do you have a linear versus a quadratic versus an exponential type of table. So if you guys remember about linear tables, it's been a long time since we talked about linear tables. The first thing you do is you check the jumps on the left and the right. So that's the term it's not the official term. So you check to see what the jump is. And so the left side, the x value should always be constant of some sort. Like whether it's going up by 1s or 2s, it should always stay the same. That way you can compare to see the type of relationship on the right side. So your x value should always be continuously going up or down. So this one starts at 4. My printer doesn't work too well. So it goes 4 to 5, which is plus 1. 5 to 6, plus 1. 6 to 7, plus 1. So the way a linear function works, and you guys, you know this, linear has a constant slope. So what we're looking for is on the right side to make sure that the jump is a consistent addition. So we go from 13 to 16, so 13 to 16 is plus 3, 16 to 19, plus 3, 19 to 22, plus 3. So, the way this works is, remember, slope is rise over run. And slope is the change in y, so it's y2 minus y1 over x2 minus x1. So the way it works is it's just the change in y over change in x. So for this one, to find the slope using a table, find a slope using my handwriting so bad. To find the slope using a table, you do the change in y. So you do the y jump over the x jump. So in this case, the y jump is 3 over 1, which is just 3. So the slope for this linear function would be 3. Sometimes they don't always jump by 1s over here, so if it was like jumping by 2s, you'd have 3 over 2 or whatever. So remember, the y is the rise, the run is the x, so that's why it's y jump over x jump. So that's how you would, interpret a linear table. A function is linear if the first jumps are constant. So it's a linear function if the first jumps are all the same. First y jumps are all the same. So it's linear if your first set of jumps on the y values are all the same value. So this one's linear. But let's take a look at a quadratic. I'm specifically going to really compare linear and quadratic because they're kind of the most similar. So again, the jumps on the left side, your x's should always be consistent of some sort. So it goes from -1 to 0, so it's plus 1. 0 to 1, plus 1. 1 to 2, plus 1. But let's check out the right side. How do we get from 10 to 13? Well, that's plus 3. 13 to 18. Well, 13 to 18 is plus 5. 18 to 25. And if you're struggling, you can use a calculator and, you can do, how do you get from 18 to 25? You can do 25 minus 18. And so that's 7. So what you're going to do is figure out the jumps from each one. So if you notice, the linear one, your first set of jumps here are all the same. Great. That makes it linear. The first y jumps are all the same. Now a quadratic, if you notice, the first set of y jumps here, they're not the same. We have plus 3, plus 5, plus 7. What's cool about a quadratic is it's actually the second set of jumps. So then you're going to make a second set. So how do we get from 3 to 5? That's plus 2. How do we get from 5 to 7? That's plus 2. And the second set of jumps is the same. So it's quadratic one's second set of jumps. of y jumps is the same. And so the cool thing about that is a linear function is a degree 1. So, you know, when we talked about polynomials, we talked about degree. So linear functions are like, you know, y equals 2x plus 1. X really has an exponent of 1 here, right? So these are degree 1 functions, degree 1. A quadratic is something like, I'm just making stuff up, like 2x squared plus 3x plus 2. The degree of this one is, you know, the biggest exponent's the degree. So this is degree 2. And so the reason why it's the first set of jumps on a linear function is it's because it's degree 1. The reason why it's a second set of jumps for a quadratic is because it's degree 2. Isn't that kind of cool? So that's the difference between linear and quadratic. These are kind of similar because they're both polynomials. They have degrees, you know, they start with x squared, x to the 1, whatever it is. You know, we could also compare like cubic functions, x to the third. And to check an x to the third table, you would check the third set of jumps. You would keep going. We're just going to focus on linear and quadratic, though, because those are the functions we really studied in Algebra 1. The last type of function we studied in Algebra 1 was an exponential function. And exponentials come in the form, you know, y equals a times b to the x. And the exponent is where you have your variable. And so exponentials behave, you know, they either get really big really quickly or they get really small really quickly, whatever it may be. And so exponentials, to tell if you have an exponential table, it's usually kind of easy because they get really big or really small. So obviously over here, like 13, 16, 19, 22, it's going up pretty slowly. This one is increasing quicker. You know, it's going up by 3, then 5, then 7. But it's not drastic. This is getting really big. You know, you start at 20. Here it goes 10 to 25, 13 to 22. But here we're going from 2 to 54. And so exponentials, using some common sense, you know, it goes from 2 to 54 in 3 steps. So the hint to telling if you have an exponential or not is it just gets really big really quickly or really small really quickly. It depends, you know, if it's growth or decay. So, you know, check your jumps, you know, on the left side, plus 1, plus 1, plus 1. The left side should always be something simple. But on the right side, I'm going to use a different color. Let's just check to see, like, let's imagine that we're adding. How do we get from 2 to 6? Well, 2 to 6 would be plus 4. 6 to 18 would be plus 12. 18 to 54, 54 minus 18 is 36. Plus 36. Okay, well, that's definitely not linear, right? It's not going up by the same thing each time. We could check the second jumps to see if it's quadratic. How do we get from 4 to 12, you know, plus 8? 12 to 36. So you could do 36 minus 12, get 24. Plus 24. Okay, this isn't consistent either. So it's not quadratic. So it's not linear. Not linear. It's not quadratic. So if you remember, exponential is all about the multiplier. So remember, it's your b value is your multiplier. So this is your multiplier. And so the way to figure out if a table is exponential or not is actually each time it's going to be multiplying or dividing by the same thing. And so I taught you guys this once upon a time. To figure out what the multiplier is, you just take the second one and divide it by the previous one. So to figure out the multiplier, you're going to do 6 divided by 2 is 3. So the jump is really you're multiplying by 3. And then let's see if that's true. So 2 times 3 is 6, and let's see if we keep going. 18 divided by 6 is 3, right? 6 times 3 is 18. 18 times 3, 54. So what we're really doing each time is multiplying by 3. Multiplying by 3 each time. So that means it's exponential, and we know that our b value is 3. So we can tell by the multiplier, right? You know, our b value represents our multiplier. Our a value, too, I'm going to show you guys how to write the equations. The a value is just the y-intercept, which is the 0, comma, whatever. So really our function is 2 times 3 to the x, because the a value, this tells you your a value would be 2. So we're going to do another set of examples. So if we have a linear function, remember it's going to go up by the same time on the first set of jumps. Quadratic doesn't go up the same on the first set of jumps, but the second set. And then an exponential, you can usually tell it's exponential by the values getting really big or really small. So then just try finding the multiplier. Do the second one divided by the first one, and then see if that matches the rest of the table. All right, so let's try this one. Let's check the jumps. So -4 to 0, so you add 4. 0 to 4, you add 4. 4 to 8, you add 4. The left side, 10 to 4. So now we're getting smaller, right? We're going from 10 to 4. So we're not adding something, we're actually subtracting something. So how do we get from 10 to 4? You subtract 6. 4 to -2, subtract 6. -2 to -8, you subtract 6. All right, well, our first set of jumps is the same, so this is linear. If you wanted to find slope real quick, you know, it's the y jump over the x jump. So in this case, your slope would be -6 over 4, which if you reduce it would be -3/2. You don't have to reduce it. I'm not looking for a reduce, but you know, if you want to. So this one's linear. We can find the slope. Let's try the next one. Let's check the jumps. 0 to 2, so we add 2. 2 to 4, add 2. 4 to 6, add 2. So the left side doesn't have to always be +1. The first set I started out kind of easy. All we care about on the left side is the left side has to be consistent for us to be able to see the relationship on the other side. So because we know we were going up by 4, we were able to see that this side's also consistent. We can find the slope. No matter the relationship, the left side just has to be consistent, because if it's going up randomly, like it's not creating a pattern for us to be able to find the multiplier or the slope or the quadratic value or whatever. So all you're looking for on the left side is just making sure that it goes up. And I'm always going to give you guys problems that are consistent, so don't worry about that. All right, let's check the right side. How do we get from -3 to -9? So you're getting more negative. So -3 minus what gives you -9? -6. How do we get from -9 to -31? If you wanted to figure out what it is, you know, you can go backwards. -31 minus -9 is -22. So we subtracted 22. So this is -22. And then -69 minus -31 is -38. So the first set of jumps is not consistent. Great. Well, let's check the second set. -22 minus -6 is -16. -38 minus -22 is -16. So we subtracted 16 both times. So our second set matches. So that means this is a quadratic. Sweet, because the second set of jumps, the second set of the y jumps is the same. So that means it's a quadratic. So I just want to focus on the negatives again real quick for this one. So to figure out, you know, -3 minus what gives you -9, -6. Remember, you can work backwards. So just like up here, to figure out that it's adding 3 each time, we did 13 minus 10. So 13 minus 10 is 3. 18 minus what is gives you, so you like, to figure out the jump, you could have done 18 minus 13 and gotten, oh, it's 5. The next jump, 25 minus 18 gives you 7. So you can do the same thing with negatives. They're just, you know, to figure out the jump, you can do -9 minus -3, and you're subtracting 6. -31 minus -9. You just have to be careful with your negatives. And the same thing for the second jumps. How did I get from -6 to -22? I subtracted something, right? -22 minus -6 is -16. So to find the jumps, and maybe I'll make a note of that down here, to find jumps for linear or quadratic, do the second number minus the previous number. Take, let's say, like, take the number that you're on minus the previous number. So yeah, so to find any jump, take the number that you want minus the previous number to find that jump between those two. And that works for the second jumps too. So this one's quadratic. We can't get a lot about quadratics just from looking at the table. We can identify when it's quadratic using the second set of jumps. Let's check the third table. Negative 2 to 0 is plus 2. 0 to 2 is plus 2. 2 to 4 is plus 2. Great. Left side's consistent. We're good to go. The right side. Okay. Well, if we just take a look at the table first. We're going from 320 down to 5 in a few steps. So this is already my hint that this is exponential. The jumps are huge, right? Like, how do we get from 320 to 80? Well, we subtract something. So, do the number minus the previous number. So 80 minus 320 is negative 240. So that means we subtracted 240. And then to get from 80 to 20, you subtract 60. And then from 20 to 5, you subtract 15. Those are not the same. And then the second jumps are also not going to be the same. They're huge, right? So my guess is this is exponential. So to find jumps for exponential, take your number divided by the previous number. So let's try 80 divided by 320. 0.25. And if you want that as a fraction, 1/4. So that means we're multiplying by 0.25. So we multiplied by 0.25 or 1/4. So let's see if that's still true. Let's try the next one. Take your number divided by the previous number. 20 divided by 80, 0.25. Multiply by 0.25, and then 5 divided by 20, 0.25. So this one's an exponential. And our b value, our multiplier, is 0.25, or I like 1/4. So real quick, I just want to talk about for the exponentials, our b value here was 3. We're multiplying by 3 each time, so this was a growth function. And in this one, we're multiplying by 1/4 each time, so this one's a decay function. And you can see that in the table, right? In this table, we go from close to 0 to 54, so it's getting bigger. In this one, we start really big at 320 and we get down to 5, so it's getting smaller. So we talked about exponential tables back in the day, but it's been a little while. So hopefully we're okay with tables. Remember, the trick is most of them are, 2 out of 3 times. It's going to be linear and quadratic. So check your first set of jumps, and then if it's not consistent, check the second set of jumps. And then exponentials, you can kind of tell just by looking at the table when it's going to be exponential, because it's getting really big or really small really quickly. And then just check the multiplier. Do your number divided by the previous number to check the jump, and check them all. So this is how to identify when a table is linear, quadratic, or exponential. Next up, we're going to talk about how we write linear equations versus exponential equations. And we're not gonna focus on writing quadratic equations. You guys look at that in Algebra 2. Writing quadratic equations is really tricky. There's a lot that goes into it, and I don't want to take that much time right now in Algebra 1. So we're just going to focus on the 2 easier ones, writing linear equations and writing exponential equations. And so to write a linear equation, you guys know that you have to have y equals mx plus b. So there's 2 things we need to know. We need to know the slope, and we need to know the y-intercept. Well, I showed you guys already how to practice finding slope using a table. And then the y-intercept is always a 0, b value. So all we have to do is find when x equals 0 to find the y-intercept. So let's try it. First of all, let's make, always make your jumps. +1, +1, +1. And then on this side, how do we get from 10 to 6? We subtract 4, 6 to 2, subtract 4, 2 to -2, subtract 4. All right, so slope is your y jumps over your x jumps. So it's -4/1, which is just -4. All right, so we know the m value, we know slope. And then the b value, go and find your when x equals 0. So here's x equals 0, so this is your y-intercept. So this is your y-intercept. So our y-intercept is 0, 6, so the b value is 6. All right, so we know both of our pieces. So just fill in. Y equals m is -4. X is part of the equation. Plus b, and our b value based on the y-intercept is 6. So there's our equation based on the table. So I'll try another one. So check your jumps on the left side. How do we get from -6 to 0? We add 6. 0 to 6, add 6. 6 to 12, add 6. This side, how do we get from -15 to 6? Well, like I said, remember if you struggle with that, just do your number minus the previous one. So what's the jump? 6 minus -15. 21. We add 21. And we can double check that with the next one. How do we get from 6 to 27? Do 27 minus 6 is, 21. 48 minus 27, 21. So to figure out your slope, so again, you need to find slope and y-intercept. So we have to fill in y equals mx plus b. So to find your slope, it's your y jumps over your x jumps. So in this case, it would be 21 over 6. And if you use your calculator or whatever, 21 divided by 6 is 3.5. You can leave it 21/6 too, or you can reduce it or whatever. 3.5 works. And then, so here's our slope value. So here's our m. Now we need to identify the y-intercept. So look for when x equals 0. Here it is. So here's my y-intercept. Again, it's 0, 6, so my b value is 6. And so we just fill into our equation. Y equals mx, m is 3.5, 3.5x plus, and our b value is 6. All right, so that's how we write linear equations. So if we have a linear table, we can write the equations. Exponentials. So real quick, just want to recap, how can you tell if a table is exponential? Another good hint is if you have crazy decimals, that's probably exponential. You're probably multiplying or dividing by something with a decimal. So that's another hint that you have an exponential table. If you're adding or subtracting, you're not going to go from having a decimal to having no decimal. So that's a good hint that you're multiplying or dividing by something. And same thing over here, right? You're going from 4 to 10 to 25 to 62.5. It's kind of random to pick up a decimal. So that's another hint that you have an exponential. So check the jumps on the left. Just make sure they're consistent. -2 to 1, add 1, add 1, add 1. We're good to go. So, this is the exponential section. So, but I just want to recap, you can tell that this one's going to be exponential just from the way, it's behaving on the table. So remember to check for exponential, do your number divide by the previous number to find what you multiplied by. So let's do 12.5 divided by 15.625. 0.8. So we're multiplying by 0.8. Let's check the next one. 10 divided by 12.5 is 0.8 times 0.8. And the last one, 8 divided by 10, it's obviously going to be 0.8 because it's 8/10. All right, so the right side always gives you your multiplier, which is your b value. And so remember, for an exponential equation, an exponential is y equals a times b to the x, where b is your multiplier and a is your y-intercept. And so this always occurs as 0, a. And then your multiplier you can just pick up from your jumps from your table. So to fill this one in, right now we've got y equals, we don't know our a value yet, times 0.8 to the x. So to fill in the a value, you just have to find the y-intercept, kind of like for linear functions. So find when x equals 0, which happens here. And so that's my y-intercept, and it's 0, 10. So my a value is then 10. So it's 10 times 0.8 to the x. Let's try one more. So over here, checking the jumps, +1, just making sure it's consistent. And then over here, again, it's going to be exponential, and we can tell because it goes from 4 to 62 real quick. So to check what we're multiplying by, just take your next number divided by your previous number. So 10 divided by 4 is our first one. 2.5. So we're multiplying by 2.5, and let's just check them all. 25 divided by 10 times 2.5, and then 62.5 divided by 25 is 2.5. So as my b value is 2.5. To find your a value, locate your y-intercept. So 0, comma, whatever. In that case, it's 0, 4. So this is my y-intercept is 0, 4. So that means my a value is 4. And then filling in, y equals 4 times 2.5 to the x. All right, guys, so for your quiz this week, the first page of notes is going to be your level 2 type questions, identifying tables, finding the slope, telling me what the jumps are, labeling your table, linear, quadratic, exponential, that kind of stuff. Your level 3 questions are going to be using a table to write equations. All right, let me know if you guys have any questions.